Welcome! Today we are working on 10A, which is solving multi-step equations. In the previous lesson, we worked on solving two-step equations. Now we're going to work on multi-step, so more than two steps. Our content objective is students will be able to solve multi-step equations by combining like terms and using distributive property, and also to check their solutions. So the difference about today and the previous lesson is now we're going to be distributing and combining like terms. Our language objective is students will be able to state the mathematical properties used when solving equations. Why am I learning this? Well, it's important for real-world problems, such as in science with finding average speed. So, some quick background knowledge here. How do we combine like terms? Well, we combine terms that are alike. So here we would combine 3x with positive 4x, which would give us a 7x. There's nothing we could combine with a positive 5y, so I'll just bring that down. And since that's all I can do, that's my final answer. Here, combining my positive 4a with my negative 3a, that gives me 1a, which is also just a. Then I'm going to combine my positive 6 with a negative 2, giving me a positive 4. So just a quick reminder, please make sure you take the sign in front of the number. Okay, that will tell you whether or not it's positive or negative. Here, same idea, combining our like terms. Here, we converted our decimals to fractions. So 4/10 is equivalent to 2/5, and 2/10 is equivalent to 1/5 once you reduce it. Combine your like terms, and you would be left with 1/15 f minus 7/15. Just a quick reminder there. So now, more background knowledge. This is a two-step equation. We would like to get rid of our constant first, leaving us with 4w equals 29. And then after that, we would get rid of the coefficient by dividing both sides by 4, leaving us with w equals 29 over 4. So notice I leave my answer improper. So for this problem, we're going to be solving equations by combining like terms. So you can see here, there are terms that I can combine. I'm going to combine a 4x with a negative 2x, which is going to leave me with 2x, bringing down this plus 7, equals 19. Now, just like yesterday, you can go ahead and get rid of the constant first. So I'm going to subtract 7 from both sides, leaving me with, let's see, negative and positive. Those are additive inverses, leaving with 0. So now I have 2x equals, this is going to be 12. Now here, I have to get rid of my coefficient. This means 2 times x, so I'm going to do the inverse, which is to divide both sides by 2. 2 divided by 2 is 1. 1 times x is x, so I have x equals 6. So this is my final answer, but again, you're going to have to be checking your work today. So just a quick reminder of how we do that. What I would do first is write down my expression, but instead of writing an x, I'm going to write down my solution, which is 6. I'm going to subtract 2, and again, instead of putting x, I'm going to put my value of 6 plus 7, and that's supposed to equal 19. Let's see, this is 24 minus 12 plus 7 equals 19. Here we have 12 plus 7 equals 19. Here we have 19 equals 19. We have a true statement, so I can confidently say the solution is x equals 6. Okay, so that's going to conclude our very first example. So let's move on to number 1. Here, let's go ahead and do the same thing. We're going to combine like terms first. So let's combine our 5x with our negative 2x, which is going to leave us with 3x plus 6 equals 21. Now, in order to isolate our variable, I'm going to focus my attention to the left side. I'm going to get rid of the constant first, so that means I'm going to subtract 6 from both sides. These are additive inverses, making 0, so now I'm left with 3x equals 15. Now I'm going to go ahead and get rid of this coefficient. This means 3 times x. So I'm going to divide both sides by 3 to do the inverse. 3 divided by 3 is 1. 1 times x is just x. Now 15 divided by 3 is 5. So again, once more, before I confidently say that my answer is 5, I'm going to check my work. I'm going to do 5 times x, which is a 5. Then I'm going to do minus 2 times x, and again, x is a 5, so let's plug that in for x. So notice I keep writing parentheses. You want to make sure you do that as well. Plus 6 equals 21. Here we have 25 minus 10 plus 6 equals 21. Here we have 15 plus 6 equals 21. Here we have 21 equals 21. So since I have a true statement, I can confidently say the solution is x equals 5. And there we have problem number 1. So let's go ahead and move on to example number 2. So now I want you to go ahead and pause the video and try this example on your own. So here, let's go ahead and check our work to see if we did the steps correctly. First things first, let's go ahead and combine like terms. I'm going to combine a 1/6 x with this negative x. Now just to help myself out, I'm going to go ahead and put a 1 right in front of that x so that I know how many there is. And let's go ahead and combine. Here we have 1/6 and a negative 1. So there's definitely more positives. How many more positives are there? Well, let's see. Let's go ahead and write negative 1.0. So a lot of my students are still struggling on where do you put the decimal with a whole number. Always ask yourself, how would you write $1? So I would write 1.00. So where does the decimal go? At the end of your whole number. Okay, so if that helps, just ask yourself, how would you write the amount in dollars? So here you have 6 minus 0, which is 6. 1 minus 1 is 0. Bring on that decimal, so I have 6/10 x minus 7 equals 18. Now what you're going to want to do is get rid of the constant, which is negative 7. So you're going to add 7 to both sides. These are multiplicative inverses, which gives you 0. So you're going to be left with 6/10 x equals, well, 18 plus 7 is 25. Now, last but not least, you're going to get rid of your coefficient. This means 6/10 times x. So the inverse would be to divide by 6/10 to both sides. 6/10 divided by 6/10 will give you 1. So here we have 1 times x, which is just x. Here I'm going to have to do some side work, but positive divided by positive is definitely a positive. So here in my side work, I'm going to do 25 divided by 6/10. You're going to have to move your decimal over 1 towards the right. So you're going to have to do the same thing here. But where is that decimal? Well, again, ask yourself, how would you write $25? You would write it as 25.00. So the decimal belongs right at the very end. So you're going to go ahead, since you moved it once to the right, you're going to also move it once to the right here. Put your decimal, bring it up. 6 goes into 2, 0 times. 6 goes into 25 4 times. With a remainder of 1, bring down that 0. 6 goes into 10 once. With a remainder of 4. Now let's bring on that 0. 6 goes into 40 6 times. Look, we have another 4. If you bring down a 0, we're going to notice we're going to divide into 40 again. So I'm going to say that my answer is positive 41 and 0.6, repeating on the 6. But real quick, another way of writing this answer would be x equals 41 and 2/3. So notice that these are equivalent, so either answers will suffice. Now, if we were to check our work, you wouldn't want to check this repeating decimal. You would want to check it with the fraction. So that's very important. Okay, make sure you want to check the fractions. So now, moving on to our next example. Again, go ahead and pause this video and try it on your own to see if you can do it correctly or not. So now, first things first, let's go ahead and combine like terms. Let's combine a 1 and 1/2 y with a negative 7/8 y. That's definitely going to be side work, so let's go ahead and figure that out. 1 and 1/2 is equivalent to 3/2 minus 7/8, where 8 is my lowest common denominator. I'm going to go ahead and multiply this denominator by 4, this numerator by 4, leaving me with 12. Now here, since it's already an 8, I'm not going to change it. I'm going to go ahead and keep it as minus 7, which is going to leave me with 5/8. So let's write that down. Now we have 5/8 y plus, let's go ahead and convert this to an improper fraction right now. 2 and 1/2 is the same as 5/2 equals, here let's also do the same. Let's convert this into a 5/3. Now it's a two-step equation just like the previous lesson, so I'm going to go ahead and get rid of the constant by subtracting 5/2 from both sides. This gives me 0. Subtract 5/2. So here, let's go ahead and do some side work. We have 5/3 minus 5/2, where the lowest common denominator is 6. You're going to have to multiply this denominator by 2, leaving me with 10. Here you're going to have to multiply this denominator by 3, so it's minus 15, which leaves me with negative 5/6. So now I'm going to go ahead and write negative 5/6 equals, what am I left with? I'm left with 5/8 y plus 0. I really don't have to write that 0 in. Now here, you're going to have to get rid of your coefficient. This means 5/8 times y. So I'm going to do the inverse, which is to divide. 5/8 divided by 5/8 is just 1. 1 times y is just y. Now, whatever you do to one side, you have to do to the other. You can go ahead and write it as a complex fraction. However, I like to show it as this, divided by 5/8. Please make sure you write it off towards the right side. If you put it towards the left, you're going to change your problem completely. So here, a negative divided by a positive is going to be a negative. Let's figure this out. It's 5/6 divided by 5/8, which is equivalent to 5/6 times the reciprocal, which is 8/5. I can see that I can cross cancel. 5 turns into 1 because you're dividing by 5. Here, 6 and 8 have a 2 in common. 6 divided by 2 is 3. 8 divided by 2 is 4. So I'm left with 4/3. So I'm going to say my answer is y equals negative 4/3. But again, you're going to want to check your answers to make sure that this is going to leave you with a true statement. If it does, your answer is correct. If it doesn't, that means you made an error somewhere and you need to look back. Okay, so we're on to number 4. So the first thing that we're going to do is notice that we have decimals as well as fractions. So I've told you in previous lessons it's going to be a lot easier to convert decimals to fraction, and the reason being is because if you look at this fraction right here, if I convert this into a decimal, we're going to have a repeating decimal, and that's a little bit too messy in my book. So what I'm going to go have you do instead is, again, convert these decimals into fractions. So, quick reminder, 1 and 25/100 is how I would read that. So I'm going to put 1 and 25/100. I'm going to realize that I can go ahead and reduce the numerator and denominator by a 25, which would leave me with 1 and 1/4, which could be read as 1 and 1/4. Notice, doesn't that look like 1 and 1/4 when you refer to it as money? Hopefully you see that connection. Otherwise, what you're going to do now is convert that to an improper fraction, which is 5/4. fourths. So what I'm going to do right now is go ahead and rewrite this, but instead of 1 and 25 hundredths, I'm going to replace it with 5 quarters. So we have negative 8 equals 5w plus 5 fourths minus 2 thirds w. Now let's go ahead and repeat the usual steps. I'm going to combine like terms first, if it's possible. So I'm going to go ahead and combine a 5w with a negative 2 thirds w. So off to the side, let's figure out what that is. We have 5 over 1 minus 2 over 3, where 3 is going to be my lowest common denominator. You're going to have to multiply this denominator by 3, giving me a new numerator of 15. Here, multiplying it by 1 is going to leave you with still a negative 2. So now I'm left with 13 over 3. So I'm going to rewrite this as 13 over 3 w, don't forget your w, plus 5 quarters is supposed to equal negative 8. Now we have a simple two-step equation. What you're going to do first, you're going to get rid of your constant. So you're going to subtract 5 fourths from both sides. This can equal 0. I'm going to go ahead and have to add it on the same side using the subtraction property of equality. Now I don't know what this is off the top of my head, so I'm going to go ahead and do some side work. I'm going to do negative 8 over 1 to make it a fraction, minus 5 fourths, where 4 is my lowest common denominator. I'm going to have to change this denominator by 4, leaving me with negative 32. And again, this doesn't have to change, but I'm just going to show you you're technically multiplying by 1. Negative 5 times 1 is negative 5, which is going to leave me with negative 37 over 4. So let's write that in. We have negative 37 over 4 equals 13 over 3w. Since we went ahead and got rid of our our constant, the next thing would be to get rid of the coefficient. So here it's 13 thirds w, which means 13 thirds times w. So I'm going to do the inverse, which is to divide by 13 thirds. 13 thirds divided by 13 thirds is just 1. Okay, so 1 times w is w. But whatever you do to one side, you must do to the other. So I'm going to go ahead and say divided by 13 thirds. So off in my side work, let's go ahead and do that. Well, first of all, what's a negative divided by a positive? It's a negative. So let's do some side work. 37 over 4 divided by 13 over 3 is equivalent to 37 over 4 times the reciprocal, which is 3 over 13. Here, I'm just going to check to see if I can cross cancel. Unfortunately, I can't. So I'm just going to multiply 37 times 3. 9 was 111 over what's 13 times 4. 2 carry the 1 is 52. So can I reduce this? Well, they're both not even, so I can't divide by 2. By the looks of it, I think that's the most that we can do. So I'm going to say W equals negative 111 over 52. But once again, you're going to have to make sure you check your work and see if you end up with a true statement. And that concludes number 4. Okay, so now we're going to be solving equations involving distributive property. So a quick reminder, what we do first is we are going to distribute 6. But something that I've noticed in the quiz was some of you guys didn't know how far to distribute. These parentheses will tell you how far to distribute your 6. So notice I'm only going to distribute up to these parentheses, sorry. So 6 times y is 6y. 6 times a negative 2, that is a negative 12. That's going to equal 60. Now it looks like a simple two-step equation that you should be familiar from the day before. You're going to go ahead and get rid of the constant first by adding 12 to both sides, which leaves me with 6y. Since this is 0, it's going to be equal to 72. Last but not least, you're going to get rid of your coefficient. 6y means 6 times y, so I'm going to go ahead and do the inverse, which is to divide by 6. 6 divided by 6 is 1. 1 times y is y equals 72 divided by 6 is 12. So my answer is y equals 12, and that's it. First things first, let's go ahead and distribute. We're going to distribute 4 to the m, which is 4m. Then we're going to distribute 4 to the negative 4. 4 times a negative 4 is a negative 16. So I'm just going to bring this down and say that it equals 16. I'm going to first get rid of the constant, and you're going to do that by adding 16 to both sides. These are additive inverses, which is 0. Here, 16 plus 16 is 32. That's supposed to equal 4m. I got rid of my constant. The next step would be to get rid of the coefficient. This means 4 times m, so I'm going to do the inverse, which means I'm going to divide by 4. Here, 4 divided by 4 is just 1. 1 times m is m. 32 divided by 4 is just 8. So my answer is m equals 8. So now, again, you would plug your value back in for m to see if you get a true statement. If you do, you know your answer is correct. If you get a false statement, that means you did something wrong and you need to go back into your work. So let's keep moving on to the next example. I'm going to go ahead and now show you what it's going to look like if you distribute a decimal. So let's go ahead and try that out. So here, you're going to only distribute as far as the parentheses. So here, I'm going to distribute 3/10 times x is just 3/10 x. 3/10 times a positive 1 2/10. Well, let's figure that out off to the side. 1 2/10 times 3/10. That's going to be 6, 3, 0, and again, just 0 and 0. So here you have 6, 3, 0. Moving your decimal places a total of 1 2 times. So 1, 2. So that's going to leave me with positive 36 hundredths. Now here, so notice I stop within the parentheses. I don't distribute any further. I'm just going to go ahead and bring down this minus 1/10 x equals 0 8/10. So notice now I'm going to have to combine like terms. So here I'm going to go ahead and combine my 3/10 x with my negative 1/10 x. Let's go ahead and figure out what that gives me. So here we definitely have more positives, so my answer is positive. How many more positives are there? Well, let's find out. 3/10 x with 1/10 x. I'm going to find the difference, and I'm going to get 2/10. There's 2/10 more x. Okay, here I'm just going to go ahead and bring that down. Plus 0 36 hundredths equals 0 8/10. Now, guys, this looks like a simple two-step equation. I'm going to go ahead and get rid of my constant first by subtracting 36 hundredths from both sides. Here, these are going to cancel and give you 0. So I am left with 2/10 x equals, well here, I'm going to have to figure this out. Are there more positives or are there more negatives? There are more positives. Let's see how many more positives there are. You're going to write 8/10. Find the difference between 36 hundredths. Put a 0 here as a placeholder. You're going to have to borrow. 10 minus 6 is 4. 7 minus 3 is 4. You're going to have a positive 44 hundredths. But now, after you got rid of your constant, you're going to have to get rid of the coefficient. Go ahead and let's see. We have 2/10 times x. So I'm going to do the inverse, which is to divide both sides by 2/10. Leaving me with, well, 2/10 divided by 2/10 is 1. 1 times x is just x. Here we're going to have to do some side work. We have 44 hundredths divided by 2/10. Moving this decimal over once to the right. Here, notice I'm only going to move it once to the right as well. Some of you have a tendency to want to go all the way and do 2. If you only move it once here, you're going to move it once here. 2 cannot go into 0, so I'm going to put an x there. 2 can go into 4 2 times. with a remainder of 0, but bring down that 4. 2 goes into 4 times, 2 times evenly. So my answer is going to be a positive 2 2/10. But once more, you're going to want to go ahead and plug this value back in to check to see if you end up with a true statement, to see whether or not your answer is correct. Okay, so for number 7, I know this problem looks a little bit intimidating, but let's just go ahead and take it step by step and see where it leads us. So the very first thing I'm actually going to suggest that you do is go ahead and convert these mixed numbers into improper fractions. So I'm going to rewrite it. Now I'm going to have 8/3. Instead of negative 3 1/2, I'm going to say that's equivalent to negative 7.5k. We're going to go ahead and put plus 1, close the parentheses. We're going to add 3/2 equals 41.5 is equivalent to 83/2. So now that I went ahead and did that, I'm going to do the normal steps as usual. So the first thing that you actually want to do is, we've talked about distributing, we've talked about combining like terms, but which one are we going to do first? Well, if you think about distributing and you think about combining like terms, distributing is basically multiplication, and combining like terms is essentially addition. When we think of order of operation, what should come first? Hopefully you're thinking multiplication. So what should we do first in this case? We would say distributing, because that's multiplication. So let's do that. We're going to distribute 8/3 times a negative 7/2. Let's do some side work real quick. 8/3 times a negative 7/2. Let's go ahead and mark that's going to be a negative so that I don't forget right now. I'm going to check to see if I can cross cancel. Well, let's see. The 8 and the 2 can be divided by 2. 8 divided by 2 is 4. 2 divided by 2 is 1, leaving me with 28/3. It is negative, but I already took care of it here. So let's write that. We have a negative 28/3 k. Can't forget that k. So now I'm going to distribute 8/3 to the positive 1. Well, that's easy. That's a positive 8/3. So notice I'm going to stop my distributing because, again, the parentheses tell you how far you need to go. Please do not go past that. I'm going to go ahead and bring down the plus 3/2 equals 83/2. Now that I went ahead and distributed, I'm going to check to see if I can combine like terms. In this case, I can. So let's go ahead and do that. I'm going to combine a positive 8/3 with a positive 3/2. Let's go ahead and show our work here. We have 8/3 plus 3/2. Our lowest common denominator is going to be a 6. So let's see, we're going to multiply this by 2, leaving us with 16. Here we're going to multiply this by 3. So positive 3 times 3 is a positive 9, which is going to equal 25/6. So let's write that down. Now, well, first of all, let's bring this down real quick. We have a negative 28/3k. Since this is positive, we're going to put plus. We already got our answer. It's 25/6. Equals 83/2. Now it's just like a two-step equation, just like before. I'm going to go ahead and get rid of the constant first. That means I'm going to have to subtract 25/6 to both sides. Notice this is going to give me 0 because they're additive inverses, which means they're just opposites of each other. Now here I'm going to go ahead and compute this off to the side. We have 83/2 minus 25/6. My lowest common denominator is going to be a 6. So here I'm going to have to multiply this by 3. 83 times 3, well, let's see, that is 249. Here, you don't have to change it, it's already a 6, so I'm going to go ahead and keep it as minus 25. So that's going to give me 224/6. So let's write that down. So now I'm left with a negative 28/3k equals, and this we got it to be 224. Ooh, wait a second. we can reduce this. We can reduce this by 2, which would take our numbers down to 112 over 3. So let's write that instead, 112 over 3. So is it wrong if you left the number like this? No, but you're going to make it a lot easier for yourself if you can make the numbers as small as possible. So always reduce whenever you can. So now let's go ahead and get rid of this coefficient. Negative 28 over 3k means negative 28 thirds times k. So let's do the inverse, which in this case means you're going to have to divide both sides by 28 thirds. This is going to give you a 1. 1 times k is just k. Whatever you do on one side, you must do to the other. So I'm going to go ahead and divide that by 28. Ooh, not 28, negative 28 over 3. A positive divided by a negative is a negative. So let's mark that right away so we don't forget. So now let's do our side work. We have 112 over 3 divided by a 28 over 3. Notice I didn't write the sign because I already took care of it here. But now this is equivalent to 112 over 3 times the reciprocal of this, which would be 3 over 28. So I'm going to notice that I can definitely cross cancel. I'm going to go ahead and divide these by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. Now here, for sure, I know that I can divide it by 2 because they're even numbers. So that's going to be, let's see, 56 divided by 2. This is going to be 14. So I have 56 over 14. Now, looking at this fraction, I actually can reduce it a little bit further. I can reduce by 7. So if I divide this by 7, I'm going to end up with, let's see, 8 over 2. Oops. And what's nice is 8 divided by 2 is a whole number. It's just 4. So guess what? Our final answer is k equals negative 4. So this one was definitely more time consuming, but step by step, nothing was different. Okay, all the steps were familiar. So once more, you can go ahead and plug this back in for k and to see if it works. If you end up with a true statement, you know your answer is correct. If not, you need to go back in your work and double check to see where the mistake occurred. So that concludes our lesson for today. Thank you so much for tuning in. If you have any questions, feel free to email me anytime. Thank you.